Havens, and this is CHKC, and we are from Harmony School of Innovation from Fort Worth, Texas, and we are doing acid-base titration for our chemistry STEM project. Titration is a slow addition of one solution of a known concentration, called a titrant, to a known volume of another solution of unknown concentration until the reaction reaches neutralization, which is often indicated by a color change. Our materials that we need are
the Akpinar flask or beaker, excess amount of standard solution or titrant, a precisely measured amount of analyte. This will be used to make the solution of known concentration indicator, the calibrated burette, and then the burette stand.
And the procedures, it's going to be about 15 steps, and we'll kind of summarize those. Right now we don't have all of our materials, so we are currently unable to perform the experiment, but we will read some of our procedure. Number one, before beginning the experiment, we will need all the materials necessary, which we currently do not have.
Number two, we'll measure the precise amount of analyte when we receive this, because this will make up the solution of the unknown concentration.
Alright, number three is quantitatively transfer the analyte into a beaker or Erlenmeyer flask. Make sure to rinse all of solid analyte into the beaker or Erlenmeyer flask with distilled water.
And number four, once we get this distilled water, we add it until the analyte is fully dissolved. Then we measure and record the volume of the solution. The process of titration will solve for the concentration of the solution.
Number five is we will add 4 to 5 drops of the appropriate color indicator into the beaker.
And then 6, we'll swirl the beaker in order to mix the aqueous solution of the analyte and the drops of the indicator.
Number 7 is we will fill the burettes with an excess amount of titrant. The titrant is a standard solution of known concentration and should be in aqueous form.
Number 8, we clamp the burette and move it carefully to a burette stand. The tip of the burette should not be touching any surfaces.
Number 9, we will place the beaker or Erlenmeyer flask containing the aqueous solution of unknown concentration under the burette.
Number 10, we'll record the initial volume of the burette. We'll make sure to measure it at the bottom of the Mencius.
Number 11, we will turn on the stopcock tap of the burette so that standard solution is added to the beaker. This should cause a color change. To be sure to swirl the beaker or Erlenmeyer flask until the color disappears.
Number 12, we'll repeat all the steps above until the color does not disappear. This means once the color does disappear, it will mean that we'll have reached the end point.
Once we have reached the end point, we will stop, and that is the point in which the reactant within the solution of unknown concentration has been completely neutralized. We will be able to tell that we've reached the end point because the color will change.
And then number 14, second to last least, we'll measure and record our final volume of the burette, and then we'll calculate the volume of the standard solution used by subtracting the initial volume of the measurement from the final volume of the measurement of the burette.
And number 15, our last step, we will now perform the necessary calculations in order to attain the concentration of the unknown solution.
So those are our materials and procedures. We'll get back to you once we get everything. See you soon.